Hi guys, welcome to my YouTube channel. I am Miss Longo. Today we are going to explore the fundamental concept of forces in engineering components. We'll be looking into the different types of forces including tensile, compressive, shearing forces, and learn how to calculate moments and stress in various engineering applications. In this session, we'll be discussing the basics of forces in engineering, covering topics such as components of forces, moments, and stress. After this session, we'll be able to resolve horizontal and vertical components. We'll be knowing the types of forces. We'll be knowing how to find resultants of parallelogram and a triangle, and we'll be able to define moments and how to calculate it, and we'll be able to define stress and how to calculate stress. To start by tensile forces. Tensile forces, they are also known as pulling forces, and pulling forces occurs when an object is stretched or being pulled apart. In this type of a force, it causes an object to elongate or extend. For example, I've given you guys two boys who are pulling a rope. That's an example of a tensile force. Then we're gonna move to compressive forces. Compressive forces, they are also known as squeezing forces, and it occurs when an object is compressed or being squeezed together. We know that the role of a compressive force is to reduce an object surface area or the volume. For example, I've given a sponge which is being squeezed. Then we're gonna move to shearing forces. Shearing forces, they are also known as sliding forces, which occurs when an object is subjected to a force that causes it to deform by sliding or rotating. For example, I've given a person who's cutting a paper with a scissor. Then now we're gonna move straight to how to calculate vertical and horizontal components. I've said, now I'm going to show you guys on how we calculate our vertical component and our horizontal component. If we want to calculate our vertical component and our horizontal component, we are going to apply trig ratios, which we have learned in mathematics. We are going to apply SOHCAHTOA. If we want to calculate our vertical component, we are going to say that our vertical component, it is equals to F sine an angle, and our horizontal component, it is equals to F cos an angle. I'm going to show you guys on how do we calculate a resultant of a triangle. If we want a resultant, in this case, resultant is the one with the blue arrow. If we want that side, it means that we are going to add the two sides, the side AC and BC. It means that our resultant in this situation, it is equals to force P plus force R. That's how we find a resultant of a triangle. Now going to move to parallelogram. For instance, in this example, we are given that force 1, it is 80 newtons, and force 2, it is 100 newtons. If we are given that we have angle 60 and angle 120, and we know that some of the interior angles add up to 180 degrees, so 60 plus 120 is 80 degrees. So the first thing that we're going to do when we want to find the resultant of a parallelogram, we are going to draw our F1 and our F2. Then after, we're going to draw our resultant. The result, if we want to find resultants of parallelogram, we're going to use the same method that we've used in order to find the resultant of a triangle. Resultant of a parallelogram, it is equals to force 1 plus force 2, which is 100 plus 80, which gives us 180 newtons. That's how we find our resultant of a parallelogram. I'm going to continue with stress, and we know that stress, it is defined as a force per unit area, and SI unit for stress, it is Nm cubed. Then we have different types of stresses. We can talk about tensile stress, and we said that tensile stress occurs when an object is being pulled, or being pulled by a rope. Then we have compressive, and we know that compressive, it is when an object it is being squeezed in order to reduce surface area or the volume of an object. Then we have shear stress, and we know that shear stress, it is the one which doesn't reduce surface area of an object. For example, let's say I'm gonna start with the one for a round. Let's say we are given a cylinder here, and that's saying that the force, it is 100 newtons and the area, it is 0.5 meters cubed. We know that stress, it is equals to force divided by area. Then our force, it is 100 newtons, and then our area, it is 0.5. It means our answer for stress, it will be 200 newtons cubed. That's the final answer for stress. Then now we are going to move to square. To show you example number 2 of a stress, whereby we'll be calculating for a square. In this situation, we're given that our radius, it is 0.1 meters for a cylinder. Then the mass for an object, it is 200 kg. Then firstly, we have to calculate a force, and we know that force, it is equals to mg, and g, it is always constant, it is 9.81. then our m is 200, so we're going to multiply our mass by 9.81, which will give us 1862 newtons. Then we're going to move to area, and we know that area of a cylinder, it is pi r squared. Then our radius, it is 0.1. Then our answer will be 0.03 meters cubed. Then we know that stress, it is equals to force divided by area, and we found out that our force, it is 1962 newtons. Then we're going to divide that force by 0.03. It means that our stress, it is 62,452.39 newtons meters cubed. Today I've covered how to calculate vertical and horizontal components, how to calculate moments and stress, and different types of moments. And we know that moments, it is defined as a product of an object's force and its distance covered, and the SI unit for moments, it is newtons per meters. In this example, we are given that the mass of an object, it is 10 kg, and the distance between a pivot and an object, it is 0.3 meters, and we are required to calculate moments. The first thing that we have to do is to calculate the force, and we know that the force, it is calculated as mass times gravitational force, and we know that gravitational, it is always constant, it is 9.81. so we are going to multiply our mass by 9.81, and it is going to give us 98.1 newtons. We know that moments, it is a product of force and distance. Then we're going to multiply our force, which is 98.1, by 0.3, which is going to give us 29.43 newtons per meters. That's our moments, and that's how we calculate moments.